To finish off the linked list ranking problem, we just need to describe how we do the independent set. So there is a relatively easy way to do it with the randomized algorithm. I'm not going to go into the details. Basically, just flip a coin, and independent set is elements you have rolled head for them, and successors with the successor that you have rolled tails for. But there's another way that just do it deterministically with 3 colors. And of course, if you can color every element such that all the colors are independent sets, then we can take the independent set with the most popular color, or with the most colors, and that will guarantee an independence of size at least n over 3. So here we would like to color the list with 3 colors such that every color is actually an independent set. Okay, how do we do this? First, we decompose the linked list into a bunch of forward lists and a backward list. So forward list is a list that just goes to the right in the list. So 3 points to 5, 5 points to 8, 8 points to 2. That's a forward list. Now we can see that 2 is pointing backward because the successor of 2 is at position at an index before 2 itself. Okay, so that gives you a black forward list. Then we have another red forward list and a blue forward list. Then we have a red backward list and a black backward list. Okay. Obviously, given an element, we could relatively easily tell whether it's part of the forward list or backward list. Okay. In particular, if before, so when we look at 8, the element that points to 8 is before 8, and the element that 8 points to is after, so therefore 8 is part of a forward list, and it's kind of in the middle of the forward list. Okay, so how do we do the coloring? So first you color the forward list with red and blue, starting from the red color, right? So the starting position of every forward list is colored red. For example, this is colored red. Then the next element is blue, red, blue, red. Similarly, for the red forward list, you have starting from red, blue, and so on. The only exception is that you don't color the tails. So the tails are not colored. Then you do the opposite for the backward lists, except this time you do it with green and the blue. Okay, and this gives you 3 coloring. Might look a bit strange. Why does this give a 3 coloring? But I'll just try to explain it here. Okay, so let's say let's just look at the forward list, because the backward list is going to be the same. When you have a forward list, basically it goes like this. Okay, and then it ends. So here we do not color this one, so this one is not going to be colored. Okay, and also initially we start with coloring this one red, right? So this one is colored red, this one is colored red, and all the other elements are colored blue. What we can observe here is that the blue elements are always middle of the elements, middle of the list. They cannot, because we don't color the tail, so therefore blue, an element that is colored blue cannot be tail, and also cannot be the first element of list. So basically every blue element has the property that it is pointing to an element coming from before, and it points to somebody after it. And both of them will be colored red, or either not colored at all. Okay, so for this blue element, both before and after is colored red, but for this blue element, the before is colored red, but the after is not colored because it's a tail. Then when we color the backwards list, this is gonna be the beginning of a backward list. Okay, because by assumption, this element, the forward list ends here, so X cannot be pointing something after, it has to point to something before. So this is going to be the starting point of a backwards list, which means that it will be colored green. So therefore this blue element will always be pointing to either a red element or a green element. So therefore the blue elements are independent sets. And similarly, red elements are also independent sets because of the same property that you always start with red, and in the backwards list you do not have red color, so that's obviously easy. And same for the green. In the forward list you don't have red color, so therefore the only time green appears is in the backward list, and of course you alternate between green, blue, so obviously green is also going to be independent. So that gives us a way to describe the colorings, except that I have to tell you how to do the actual coloring. Okay, so now we have a description of the coloring, but the process of finding out what is the color is actually a little bit complicated, because in fact this is kind of an almost a Boolean list ranking, right? Because say this is the so let's look at this black forward list. It is equivalent to coloring everything with zeros and ones, okay, whereas you go from 0 to 1, 0 to 1, 0 to 1, and this is actually almost like list ranking. So it might seem like this process should be as complicated as list ranking, but we're going to use a very interesting idea that will essentially solve this coloring problem for us, and then with that we'll be done with the list ranking problem.